Okay, geometry class. I'm going to talk to you a little bit about circles, circumference, and the distance of sectors around our parts of circles around the edges. First, I'm going to identify what a minor arc, major arc, and semicircle are. Semicircle is probably what you would guess, 180 degrees halfway around the circle. To identify a semicircle such as this circle up here, you need to identify 3 letters that the semicircle would go through, such as through CDF, CEF, if you're talking about this half of the circle. If you're talking about the other half of the circle, that would be CBF. That would be how to identify a semicircle. A minor arc is any arc that is less than 180 degrees. So a minor arc would be less than 180 degrees. Something like CD, DE, EF, BC, those are all minor arcs. Major arcs are arcs that are over 180 degrees. Now you can't label a major arc using 2 letters, because if I was talking about BC, would I be talking about BC the minor arc or BC the major arc? So 3 letters are needed to identify a major arc. So I would say arc BFC or BEC or BDC, those are all the same major arcs, because I start at B, go through any one of the letters, and I end at C. So that is the difference between minor arc, major arc, and semicircle. Central angle of a circle is, you know that a circle has 360 degrees. If I identify the center here, so that's 360 degrees on the inside and around the outside as well. So 360 degrees, our correlation with the central angle. If this central angle here is 60 degrees, then this arc measure is also 60 degrees. If I have another angle coming off the edge of here, and this one here is 35 degrees, then this central angle is 35 degrees. You name a central angle like CAB, and the measure of angle CAB would then be 95 degrees. So the central angle is equal to the arc angle around the outside of the edge. As I scroll down here, it may ask for some different arc lengths, such as major angle VST, major angle or just angle VST looks to be under 180 degrees. So since this is 360 degrees, minus 114, minus 90, I would have angle VST. If it just has angle SV, we're just talking about that angle right there. Since this is a semicircle, that's 90 degrees. I know angle VS or SV is also equal to 90 degrees. As I come down, I'm going to talk about angle, the actual length of the angles. So as we know, a circle is 360 degrees. To find the circumference, you know the circumference is equal to the diameter times pi. That is how you find the circumference of a circle. Well, if the radius is 9 inches, that makes the circumference 18 pi. So that would be the circumference of this circle. If I only wanted to find the distance, or how long in actual length 20 degrees of that circle would be, well, 20 degrees is out of 360. If I lop off the zeros, it's 1/18 of the circumference of the circle. So if my circumference of the circle is 18 pi, then I would take 18 pi times 1/18 of the circle, meaning that the 18s would cancel and the length of that arc is actually pi, or 3.14 inches. So I would be able to say 3.14 inches is the length of that arc. This problem down here, this is 90 degrees. So if I wanted to find the arc length in centimeters of that arc, I know that 90 degrees reduced is 1/4 of the circumference of the circle. Since the radius is 10 centimeters, then the diameter is 20 pi. So if I take 1/4 times 20 pi, that reduces to 5 pi, or 5 times 3.14. That would be the actual length of that in centimeters. Sometimes you'll be asked to answer in terms of pi. If so, bam, there it is. If not, then I'll actually multiply 5 times pi, 15 point something, which would give me the length of that in centimeters. For number 31, this time it tells me my diameter. My diameter is 15, so therefore the circumference is going to be 15 pi. 120 degrees is 1/3 of the circle. So if I divide that by 3, once again, that arc length is 5 pi. Obviously, a semicircle, which is half of the circle, if the if the diameter is 22 pi, then I know that half of that is going to be 11 pi, and 11 pi is going to be the length of that arc. There are many different things you can do with finding some of the lengths of the arcs in terms of pi or in actual distance, but this section has to do with arc lengths, major arcs, minor arcs, and things such as that. Feel free to replay this. I am going to assign you one worksheet, worksheet 10.6, that goes along with this section. I also assigned 3 cons that kind of reinforce those ideas as well. Some of them with equations, but I think you'll be smart enough to figure out how the equations work, and you just have to solve. On those, if you have any problems, you can watch the Khan Academy tutorial, but hopefully this helps a little bit with the arc lengths. Like always, send me an email or get a hold of me somehow if you have any questions. I won't be grading the actual paper assignment. There'll be practice like normal. I would say do enough of them that you know how to find the arc lengths of these circumferences, or of these circles. Make sure you complete the 3 cons, and those 3 will be getting in the grade book. The next section will be about areas and sectors, and finding the areas of these sectors, and I'll be posting that here sometime soon. That pretty much wraps up the chapter after those 2 sections. So I will be trying to put together a test for you guys. Not sure exactly how I'm going to do that yet, whether it'll be Google Classroom or send you a copy of it and you can scan it, take a picture of it, do whatever, and send it back. But I'll figure that out as the week goes. I'll post one more section this week to have done by Friday, and then we'll start looking at what to do next. Hope you guys have a good week. Hopefully this helps a little bit, and let me know if you have any questions. Thank you.